In 1929, a Japanese farmer named Masanobu Fukuoka did something his neighbors called insane. He quit. Quit plowing, quit weeding, quit fertilizing, quit everything conventional agriculture said was necessary. He scattered seeds on his fields, covered them with straw, and walked away. Within 3 years, his rice and barley yields matched the best conventional farms in Japan, using zero labor after initial planting, zero inputs, zero maintenance. For 40 years, he documented the system. His 1975 book, The One Straw Revolution, sold over 1 million copies worldwide. Then something strange happened. No agricultural university adopted his methods. No government extension service taught it. The book was filed under philosophy instead of agriculture. And here's what should make you furious. The reason they buried it wasn't because it didn't work. It's because it worked too well. Fukuoka's method is called natural farming, or do-nothing farming. The name is misleading. It's not about being lazy. It's about working with nature instead of fighting it. And here's the dangerous question he asked that agricultural universities don't want you asking. What if we're not supposed to be working this hard? Think about it. In a forest, nobody tills, nobody weeds, nobody fertilizes, and somehow forests have been feeding themselves for 400 million years without buying a single bag of Miracle-Gro. Trees drop seeds, they germinate in leaf litter, they grow into new trees. The system perpetuates itself without human intervention. Fukuoka looked at that and said, what if food crops can do the same thing? What if all this labor, tilling, weeding, spraying, is actually breaking the system that would otherwise take care of itself? He tested it, and the results threatened to make an entire industry obsolete. Stay with me, because in 90 seconds, I'll show you why equipment manufacturers fought to keep this quiet. Here's how it works. In fall, Fukuoka scattered rice and barley seeds directly onto fields. No plowing. Seeds landed on last year's stubble and decomposing straw. He covered them with straw mulch, about 4 inches thick. Seeds germinated through mulch, rooted into undisturbed soil below. Straw suppressed weeds, conserved moisture, gradually decomposed, fertilizing soil. In spring, when barley was 8 inches tall, he scattered clover seeds among it. Clover germinated, grew low while barley matured overhead. When he harvested barley in May, he left straw on the field. Clover kept growing, covering soil, fixing nitrogen from air through root nodules. In June, he scattered rice seeds directly into clover. Rice germinated, grew above clover. When rice matured in fall, he harvested it, left straw, cycle repeated. Rice, barley, clover, all growing in succession. No tillage, no bare soil, no chemicals. The yields? Japanese rice farmers in the 1960s averaged 4,500 pounds per acre using mechanization, fertilizer, pesticides. Fukuoka's farm? 4,200 to 4,800 pounds per acre using zero inputs. Same yields. Zero costs, zero labor beyond scattering seeds and harvesting. But here's what made agricultural institutions uncomfortable and why they classified this as philosophy instead of science. If Fukuoka's method worked, it invalidated the entire industrial agriculture model. No need for tractors, plows, tillers. Equipment manufacturers selling $500,000 machines? Unnecessary. No market for synthetic fertilizer. Chemical companies selling $200 billion annually? Obsolete. No demand for herbicides. Pesticide corporations? Out of business. An industry built on annual sales of equipment and consumables suddenly faced a farmer proving you could grow food with none of it and maintain those yields for decades. That's not a competitor. That's an existential threat. When Fukuoka published The One Straw Revolution in 1975, translated to English in 1978, Western universities reviewed it and dismissed it as site-specific, meaning it worked for him in Japan but couldn't scale elsewhere. But that claim falls apart fast. By 1985, farmers in over 30 countries had replicated his techniques successfully. India, Philippines, Thailand, Kenya, Brazil, United States. In each location, yields matched or exceeded conventional methods while eliminating labor and input costs. In 1989, Rodale Institute in Pennsylvania conducted a 5-year trial: conventional tillage versus reduced tillage versus no-till with cover crops, Fukuoka's method. Results published in 1994, no-till plots produce yields equal to conventional while reducing labor by 75%, eliminating herbicide use, increasing soil organic matter from 3% to 6%. The study was published in academic journals with limited circulation. No major agricultural media covered it. No government agency updated recommendations. USDA continued promoting tillage and chemicals as standard practice. Think about what that means. Research proved the method works. Universities buried it anyway. Because here's what really happened, and this should make you angry. The global tillage equipment market is worth $8 billion annually. Tractors, plows, tillers, all designed to turn soil. If farmers stop tilling, that market collapses. The synthetic fertilizer market is worth $200 billion annually. If cover crops and mulch provide nutrients, farmers stop buying fertilizer. The herbicide market is worth $30 billion annually. If straw mulch and continuous cover suppress weeds, farmers stop buying chemicals. A method that eliminates all three markets simultaneously is an existential threat to agricultural industry profits. So instead of promoting it, institutions ignore it, dismiss it as experimental, and continue teaching methods requiring annual purchases. But the physics doesn't care about profit margins. Mulch suppresses weeds. Fungi build soil. Legumes fix nitrogen. These processes work whether corporations approve or not. Now here's the mechanism and why this threatens everything they've taught you about gardening. First, undisturbed soil develops structure: fungal networks, earthworm tunnels, root channels. These create pore spaces holding air and water. When you till, you destroy the structure. Soil compacts, water runs off, roots struggle. In Fukuoka's fields, decades without tillage created soil so porous he could push his hand 8 inches deep without effort. Second, continuous cover. Bare soil loses moisture through evaporation, nutrients through erosion. Fukuoka's fields were never bare. Straw mulch covered surface, clover covered between crops. This living or dead organic matter protected soil, conserved water, fed decomposers. As it broke down, it released nutrients slowly, matching plant uptake. Third, nitrogen fixation. Clover and other legumes host bacteria in root nodules, pulling nitrogen from the air, converting it into plant-available form. Healthy clover cover crop fixes 100 to 200 pounds of nitrogen per acre yearly, for free. That's equivalent to $80 to $150 worth of synthetic nitrogen. And here's what makes this insulting. You've been told you need to buy fertilizer, till your soil, pull weeds, spray chemicals, or your garden will fail. But forests don't do any of that. They've been outproducing farms since before humans existed. Fukuoka just asked, what if we stop fighting nature and start copying it? Let me show you how to implement this with a 15-minute setup producing food for 30 years. The method is establishing a perennial food forest using sheet mulching and no-till planting. You're creating a self-sustaining ecosystem requiring minimal intervention after installation. First, choose your site. Full sun, at least 6 hours daily. Any soil works, even compacted clay or sand. Second, kill existing vegetation without tilling. Lay cardboard directly on grass or weeds, 6 to 8 sheets thick. Overlapping edges 6 inches. Water thoroughly to initiate decomposition. Third, add compost. Spread 2 to 4 inches of compost or aged manure over cardboard. This is your fertility base. Fourth, add mulch. Spread 6 to 8 inches of wood chips, straw, or shredded leaves over compost. This is your weed barrier and long-term nutrient source. Fifth, plant. Push aside mulch. Cut an X in cardboard. Plant seedling or seed directly into compost below. Cover plant base with mulch, leaving small opening around stem. For perennial food forest, plant mix of fruit trees, berry bushes, perennial vegetables like asparagus, artichokes, rhubarb, and nitrogen-fixing shrubs. Space according to mature size. Goal is eventual canopy closure where plant leaves shade soil, eliminating need for mulch renewal. Time required? 15 minutes per 100 square feet to lay cardboard and mulch. Planting, 5 minutes per plant. For a 400 square foot garden with 20 plants, total setup 2 to 3 hours. Maintenance after setup. Add mulch once yearly for the first 3 years as it decomposes. After year 3, plant canopy provides shade. Leaf drop provides mulch. Maintenance drops to near zero. Now, real data proving this works for 30 years. In 1995, an Oregon homeowner established 1/4 acre food forest using Fukuoka-inspired methods. He sheet mulched the area with cardboard and wood chips, planted 15 apple trees, 20 berry bushes, nitrogen-fixing shrubs, perennial vegetables. Year 1, minimal production, plants establishing. He added wood chips twice. Year 2, first harvests, 30 pounds of berries. Maintenance, 1 wood chip application. Year 3, 150 pounds of fruit. He stopped adding mulch. Leaf drop from trees provided natural mulch. Year 5, system fully self-sustaining. Trees shaded soil, leaves mulched the ground, nitrogen-fixing shrubs fertilized surrounding plants. Annual harvest, 800 pounds. Maintenance, 2 hours yearly for pruning and harvest only. Year 10. Production peaked at 1,200 pounds annually. He stopped pruning except dead wood. Food forest had become a functioning ecosystem. Year 20, 2015. Zero maintenance beyond harvesting. System self-regulated. Birds and beneficial insects controlled pests. Leaf litter provided all fertility. Production stable at 1,000 to 1,200 pounds annually. In 2023, year 28, food forest still produces. He harvests apples, pears, berries, asparagus, rhubarb. Total labor over 28 years, approximately 100 hours, 3.5 hours yearly on average. Total harvest, approximately 25,000 pounds. Compared to conventional gardening, typical vegetable garden requires 2 to 3 hours weekly during 20-week growing season, 40 to 60 hours annually. Over 28 years, 1,120 to 1,680 hours. Food forest achieved same production with 94% less labor. This is Fukuoka's principle scaled to a backyard. Do work once, let nature maintain it, harvest for decades. But there's one more element making this revolutionary, and why seed companies hate it. Fukuoka perfected seed balls. He wrote seeds in clay powder and compost, dried them into marble-sized balls, scattered them onto fields. Clay protected seeds from birds and rodents. When rain came, clay dissolved, seeds germinated. This allows seeding without tillage. You can establish entire meadows, cover crops, grain fields by walking across land scattering seed balls. No machinery, no soil disturbance. In 2010, a Detroit group used seed balls to revegetate vacant urban lots. They mixed vegetable seeds, clover, flowers, grains into clay balls, scattered them onto compacted, contaminated soil in abandoned lots. Within 2 years, lots transformed into productive community gardens and pollinator meadows from one-time seeding event. Total cost, $50 in seeds and clay for 1 acre. Labor, 4 hours to make and scatter balls. Production, ongoing for years as perennials reseeded. This is technology that could revegetate millions of acres, feed communities in food deserts, restore ecosystems without expensive equipment or ongoing labor. But it's not taught in any agricultural program. Fukuoka's book is still classified as philosophy by most universities. Why? Because a system requiring zero inputs and minimal labor generates zero profit for agricultural supply chains. Seed balls made from local clay and saved seeds can't be patented, regulated, or monopolized. A food forest producing 30 years isn't a customer for annual seed sales. But nature doesn't need customers. Forests have been feeding themselves for millions of years. Fukuoka just reminded us we're allowed to participate. If you're tired of weekend after weekend spent weeding, watering, fighting your garden, This is your exit. 15-minute setup, decades of harvest. No till, no chemical warfare, no subscription to garden supply stores. Agricultural industry spend 50 years dismissing this as impractical. Meanwhile, thousands worldwide have been quietly using it, feeding themselves, wondering why everyone else is still tilling, weeding, spraying. Fukuoka died in 2008 at 95. His farm is still producing. No one tends it. Trees drop fruit, seeds germinate, cycle continues. That's not poetry, that's proof. If this changes how you see gardening, share it with someone exhausted from maintaining their plot. If it makes you angry this knowledge was buried in the philosophy section instead of taught as standard practice, you're paying attention. The forest doesn't ask permission to grow. Neither should you. Setup takes 15 minutes, harvest lasts 30 years, and the only thing you need to do is stop doing everything they told you was necessary.